Hi guys, in this video we will be looking at tangents. Well, it's a continuity of tangents. Remember, in our previous video we look at tangent, perpendicular. We look at tan chord actually. Yes, we look at tan chord. So in this video we're going to look at another tangent that states that a tangent to a circle is perpendicular to the radius at the point of contact. Yes, tangent to a circle is perpendicular to the radius at the point of contact. Meaning, when it's perpendicular, guys, you need to remember this term. It means that it forms 90 degrees. No? And I want you to note this. There is no proof that will be required for you to prove in terms of this theorem, right? There will be no proof that you will be required to prove, right? So in this case, it's just for enrichment and curiosity. That's why I started with this proof, so that you understand it better, where it come from, right? So, and if you're new to this channel, guys, what are you waiting for? Do the right thing. Kindly subscribe, like, and comment. Remember, you only subscribe once, right? It's free of charge. Then, if ABC is a tangent to a circle at B, you can see ABC. It's a tangent to a circle at B. We can see there's a point of contact here. Then the radius. We can say now that the radius OB is perpendicular. The radius OB. This is the radius OB. It's perpendicular to ABC. Yes. Okay. Just as I've mentioned, that it's very important, guys, that you know the proof where it come from, but the proof won't be examinable. You will apply this theorem in a more especially in a rider. So guys, whenever you work with this theorem, the reason behind this will always be tan perpendicular to radius, right? So that will be the reason behind this, guys, whenever you're working with this beautiful theorem, right? So let's look at an activity that will help us, right? Remember that whenever we work with this geometry, guys, I always want to link this with activities so that you understand how to apply it. Then once we are done with our theorems, we'll then look at those exam questions. Answering those riders and proofs will also be beneficial in our exams, guys, right? So that's why I emphasize that we should do the activity. So if you feel that you can do this, you can pause the video. You can pause the video and attempt it. Then after that, you can check your answer, right? So the question says that calculate the value of the unknown angles. We are being told that O is the center of each circle, and ABT is a tangent, right? We said calculate the value of the unknown angle, and O is the center of each circle, and ABT is a tangent. That's what it's required. So we need to calculate the unknown angles. So in this case, guys, I want you to look at this very well. We can see that this is a triangle, but yeah, the numbering, it's ABT. Oh, this should be B, not C. What I wrote here, it's a mistake, guys. So this should be B. Tangent is ABT. So what is happening here? First thing first, can you see that angle OBT is equals to 90 degrees? Why? It's because of tangent perpendicular to radi. What we have learned that here it will form 90 degrees. So here it will form 90 degrees. That's what will happen. That's your statement and reason. You get a mark for saying that statement and reason. Very important, guys. So now we need to look at the unknown angle. In this case, the unknown angle, it's one of the variable, which is x. It's one of the variable called x. So we have x. So in this case, since we have 90, so we're going to say 90 degrees plus we also have 50 degrees plus x, which is equals to 180. Why is equals to 180? This is because it's a sum of the angles of a triangle. So now I want you to add, just say 90 plus 50. What do you get, guys? That's 140, no? So we are going to have 140 plus x, which is equals to 180. You will then transpose 140 to the other side. We're going to have 180 minus 140. Then what is if in 180, when we take out 140, we'll be left with 40, right? So we'll be left with 40. So making x to be 40 degrees. So remember the reason, sum of the angles of a triangle, right? Sum of the angles of a triangle. So that makes this unknown value to be 40 degrees. I hope, guys, I hope that is clear, guys. I hope that is clear, right? Okay. We will now look at the second question. Well, the second question requires us to, as well, we have to calculate the value of the unknown angles. And O is the center of each circle, and ABT is a tangent. Yes, we're still going to use the same tangent, which is ABT. Right, so guys, I want you to analyze this very carefully. Can you see that angle ABC, it's 90 degrees? We can see that this is 90 degrees. It forms 90 degrees here, angle ABC. So it forms 90 degrees. So the reason will be tan perpendicular to radii. Tan perpendicular to radii. All right, guys, we won't rush because we don't want to crash. So for us to find x, we will, since both of them are equal to 90, we will do this. We'll say 90 is equals to x plus 35. Then let's transpose this to the other side. Then the reason is this. It's because of angle ABD. Is it D? Yes, angle ABD is equals to 35 degrees. So from here, guys, I can transpose 35 to the other side, making this to be 90 minus 35 degrees, which is equal to x. So from there, we will just say 90 minus 55, yes. So making x to be 55 degrees, right, guys? So we have x as 55 degrees. So I've stated the reason is because of ABD equals to 35 degrees. So we have x as 55. We are not done. We can see that BC, it's a diameter, and it subtends a right triangle at D, making this to be 90 degrees. So in other words, we also have y as 90 degrees. So the reason will be angle in angle in a semicircle. Yes, so we already have, remember here it's 55, here it's 90, so we can find z. So z, it's a sum of angles of a triangle. To get z, we are going to say 90 degrees plus 55 plus z, which is equals to 180 degrees. So I want us to add this. Let's just say 90 plus 55, we get 145 plus z, which is equals to 180, then 180 minus 145, therefore z is what? 180 minus 145, making z to be 35 degrees, right? Making z to be 35 degrees. So the reason, so you must now write down the reason. Sum of the angles of a triangle. Write down the reason. Sum of the angles of a triangle. Sum of the angles of a triangle. Sum of the angles of a triangle. So that's the reason. So we already calculated all the missing unknown values, right? So that's how you can apply tan perpendicular to radii, guys. That's how you can apply tan perpendicular to radii. Just as I've said, this will be very useful in a write-down, because they won't ask you about the proof, right? So remember the proof that they will ask you in tangents. I told you in our previous video that it's tan chord. Tangent chord is the one that they will ask you. All right, if you're new to this video, guys, if you're new to this channel, kindly do the right thing by subscribing, like, comment. We really appreciate you guys.